So I'm going to start directly with the in situ part, since it's better to understand what type of workflows we are referring to, and then move on to the need for high performance data management with that. So we already discussed, I think it was Kyle mentioning that workflows are underdefined. In situ workflows are even further underdefined. And in general, the idea is that in situ workflows try to overcome I/O limitations in supercomputers, and they try to share data between the different components on the different types of tasks in the workflow as data are produced. And this is, of course, an umbrella term, because at the end of the day, when we look at the traditional type of analysis associated with a numerical simulation, there are different types of technologies that we can use to do this data delivery. There are many types of shapes of workflows we can have depending on the association of these analysis, visualization, orchestration tasks with respect to the simulation. And at the end of the day, it gets even worse, because depending on how you place your tasks and how you associate resources as well, what in situ means is even more diffuse, right? So there are many areas that one can inspect in order to decide whether a workflow is in situ or not. And that's why we have always this discussion of what an in situ workflow is. And this is something that Fred is going to develop a little bit later as well. But for the scope of this very, very short talk, let's look at a very simple example, like the minimum example of what an in situ workflow can be. So I work in molecular dynamic simulations. That's one of the domains that we currently work with. And in this particular case, let's assume that we have a molecular dynamic simulation, as you mentioned before, essentially just a particle simulation. And there are different types of analysis that we can do on simulated data, including machine learning models. And scientists have this toolbox of user-defined representations and algorithms that they want to run in simulations. And in many cases, they want to be able to do this as data being produced, so that we can make smart decisions on what the simulation is doing. So in order to do that, there's a need for an intermediate data staging, data transport layers, something that we can use to move data from the simulation to the analysis. And with that, as I said before, we can make decisions on what the workflow is doing. So this is a very, very tiny example. Usually you would have something that said ensembles of thousands of simulations, and this would be embedded in an ecosystem that has all sorts of orchestration and resource management components around it. But there is one more aspect that, at least for me, in what I see when interacting with scientists, is very important, which is, okay, in situ is great, but you also want to keep that data. So you want to be able to push the intermediate analysis, data and metadata storage for further inspection. And that's a very challenging aspect as well. So overall, there are many challenges in situ workflows that are still not fully addressed. So first one is what I said, the aspect of definition, especially considering that different entities, like site operators, users, etc., have a different perspective on the terminology. And that also kind of bleeds down to all the different aspects of the workflow, including how we evaluate performance, how we interface the different components as well. One of the important aspects that is also related to the standardization lightning talk that we had is that because scientists want to use this toolbox of different components, it is not necessarily obvious to do the transformation of data that comes from one component to the other. There are format incompatibilities, there is frequency and synchronization aspects that need to be taken into account. And that is an aspect of building the right interface that is essentially it's very domain specific to some extent. So it would be nice to see if it's possible to generalize or to define these interfaces of data exchange better. And then there is another aspect that is super important, which is the dynamicity. So one of the key aspects of doing in situ is that, as I said before, we can make smart decisions of what workflow is doing. But in order to do that, sometimes we need to add, remove, or change tasks that are already in execution based on runtime analysis results. And this is really, really, really challenging. And finally, as I said before, all the aspects of keeping the data. So not just moving it around, but also preserving it asynchronously from the in situ portion of the workflow, because scientists want to record and query every piece of data that is generated for further exploration. And that is more in the area of the high performance data management that Fred is going to talk about.
Thank you, Silvina. So we'll take the lead from now for the data management part. And one of the big questions when we talk about in situ workflow is why do we need high performance? And I think it's not really about managing what comes in the workflow and what goes out the workflow, because usually the input parameters you give to your application are rather small. And if you are doing in situ, applying in situ technique to your workflow, is especially to reduce the output and not having a big amount of data at the end of the workflow that you have to analyze further later. So for this input and output data, the focus now is more on applying FAIR principle and being able to make data accessible to and interoperable with other applications. However, and Chantal mentioned that we see a rise of AI and ML workflows, and they come with different access patterns in terms of data and with a lot of small files that are accessed a lot of time by many different tasks. And so it may come with new performance issues that systems have to address. But the real need for high performance data management is for the intermediate data produced during the execution of the workflow and passed from the simulation part to the analysis part or visualization part during the execution. But we can also go a little bit further than that if we consider that all the non-scientific data that can be generated during the execution. So we can imagine that we can get monitoring and performance data to adapt the execution of the workflow depending on how it behaves on the particular machine. We can output also metadata about provenance, about whatever information we can get, derive new interesting quantities to analyze on the fly during the execution. And all of that, every single piece of data we want to produce will have an impact on the execution of the workflow itself. So the question then is now how to get this high performance when we deal with workflow generated by workflow. So there are three different parts. The first one is working on the data format with a constraint fixed by the application users and the scientific communities. But we can discuss whether it's better to optimize the write or the read of the data. In situ case, it has an impact whether we impact the producer or the consumer part, which depending on which part is the most important, usually the producing part. We have to exploit all the parallelism we can, and this workflow, in situ workflow, are running on bin machines with a lot of nodes and a lot of cores, and we have to use them to produce and consume data. We can also work about the transport method. So is it better to work directly in memory, as it has been the tradition for and big claim in the in situ community for a long time? Should we do data streaming, data staging, and file-based techniques are that bad? Are we sure of that? And last axis we can work on is data reduction, which is more than just compressing data. It's also being able to prioritize information in the data and be able to access only to what is it important and not to everything to do your analysis and visualization. And so in this landscape of high-performance data management, we have two frameworks, so HDF5 and ADIOS. I'm not here to advocate for one or the other. You know what could be my opinion on that. depending on my affiliation. But I would like rather to derive some lessons that we can learn about workflow management system. And so, because these two frameworks shared some aspects that are, I think, key to their respective success. So they both combine an IO library and a file format. And so the objective of that is to completely delegate the IOs to this dedicated subsystem and get the application rid of that and really focus on the computation part. We also have self-descriptive data, and so they brings a lot of richness thanks to the metadata associated to the scientific content. We have well-defined APIs. We can switch between transport methods and go beyond only file-based I/O. And again, and something that reminds what Kai said at the beginning. It's open and sustained software packages, so it's important to share among a large user community, to get feedback, and to be able to bring things to further develop the ecosystem and be able to promote that. But there are still some challenges. So one of them is, can we extend what has been done and what has been optimized to the production and consumption of scientific data to all the data generated by the workflow? So can we apply the same techniques to performance data, provenance data, extra analytics that we want to deal with? Or do we efficiently integrate the AI and ML components presented in the previous talk by Shantanu and Timo with our different access pattern? Or can we further decouple the different planes that are involved in the execution of in-situ workflow? So you have the application, you have the data, and you have all the control to adapt the execution depending on what's happening and all data are produced and consumed. And last but not least, how can we better understand the impact of all this intermediate data movement on the execution? How can we prevent bottlenecks, or we can minimize duplication and redundancy in your data management? And how can we dynamically adapt to everything that happens outside the execution of the workflow? Can we anticipate data movement, delay them to be as efficient as possible? And to conclude, so some of the discussion points for the breakout session. So can we drive the community towards interoperability and specialization for in-situ workflow and data management? So it's complementary to the effort of the first breakout session. And the idea is to try to move away to this ideal workflow management system that could solve every single problem at once. I really believe in letting data management system handling data and having workflow management system working on the execution and the interaction with data, but not producing and moving them. And so trying to compose different services and optimize services to build something better. And so the question is then, what are these building blocks that we need to support in-situ workflow? We already have some stuff for simulation, analysis, visualization, and data transport, but is there more? Can we plug in a provenance tool? Can we plug in monitoring and performance information? Which will be interesting to do that. And again, something that has been mentioned before, how can we define a better terminology and to be sure that when we say in-situ workflow and data management, what people mean about that, and not having this big umbrella term, but understanding what it means in terms of composition of the operation, orchestration of the workflow, what are the information we have about data management systems and stuff like that. And this will help us to go towards a standard interface for high-performance data exchange, I guess.